Thank you so much for joining us again for this webinar. This is something that STV really appreciates the opportunity to partner with ITS America to put on. And it's always fun to bring a host of panelists who we work with on various things and we really like. And this one, they always said in middle school, don't put too many words on your slides. Well, we've got a lot of videos on our slides, so this should be extra fun. I am James Kuhr. I'm in Austin, Texas. I work for STV on matters around what you're looking at today. As a consultant, I have a history in the industry, both in research and at TxDOT, and I'm now here at STV. And joining me today are Aaron Cushman. He's the ITS division manager for the city of Nashville, which is a city that might be a little bit cooler than Austin these days, which is neat. Jaime Sullivan is the Vice President of Business Development for Derq, who does a lot of neat stuff with cameras. Jaime Pierce, who's a TransVision Operations Lead for TxDOT, which is in the Fort Worth District. And then Mark Pittman, who's our Director of Transportation AI at Bentley. Mark was the founder and president and CEO of Blyncsy and was acquired by Bentley, I think, a couple of years ago. So, for this webinar today, we initially thought, let's do video, but due to some work that we're doing with Aaron, he's bringing just this really unique concept of let's use LIDAR and let's see what LIDAR can provide with us today. So I think we have a very well-rounded presentations for you today on the various ways that you can observe what's going on the roadway. And with that, I'll ask Aaron to kick us off. Go ahead, Aaron.
All right. Well, I apologize, for not having a camera. Not exactly sure what happened there. Let's see here. Let's get to, there we go. Sorry, running around here. All right, so I am Aaron Cushman. I'm the Information Technology as well as Intelligent Transportation System Division Manager for NDOT. We decided to get into LIDAR for Smart Grant Phase 1. We put together a project. One of the big things we wanted to do with LIDAR is advance NDOT's Vision Zero goals to increase, vulnerable users, our pedestrians out there. And in the process, discovered that we're going to start using LIDAR all over the place. One of the big things is, I'm sure most people understand LIDAR uses light very similar to the way radar uses. The radio waves, my brain's shutting off here this morning. But LIDAR is really cool because it allows us to, with the current deployment, to cut out different obstacles that we're seeing. So our first one that we did for Smart Grant Phase 1, let me escape out of here so I can show you, was we decided to use Clarksville Pike. And what's really nice about Clarksville Pike is we have a very big bus depot here where we were able to determine with this deployment where we needed to add extra crosswalks, mid-block crosswalks. We were able to determine where people were crossing that we didn't understand before. So it was an incredible eye-opener for us as we got going on this one. As we started looking around, we said, well, where else can we use a technology like this? And we're like, we got a very good problem. Broadway. Broadway, some of weekends can, house 20 to 30,000 people down there through Broadway. And the amount of pedestrians that are crossing through that section are pretty amazing. And I mean, this is current live view on Broadway right now. You're able to see the people walking up and down the road. You see the traffic. So some of the things that we're doing with this LIDAR is we're creating zones throughout this city, throughout the block. We're able to determine how many people are on the sidewalks, how many people are leaving the sidewalks due to the sidewalks being congested, to figure out that risk factor. What is the risk factor? When do we need to send an MPD out there to figure out what is the problem? Why are people leaving the sidewalks in mass droves and creating that risk where they're about to get run over by a vehicle? So it has been an incredible problem to have. And when you're talking, 30,000 people, let me see if I can get this to move out of my way real quick here. There we go. Just for instance here, this is what one of the other cool features on this, working with, first of all, let's bring in, we have partnered with Vanderbilt University. On phase one, we also worked with UT Chattanooga, TSU, to come up with different public outreaches, and the actual technology that you're seeing here, this live viewer, was created by Vanderbilt. So when we decided to do the Broadway project, we brought Vanderbilt in. This is just a small 5-minute section that was recorded during we were able to pull this data back up and view this data. This is 4th of July, just a 5-minute little glimpse of what 4th of July looks like down on Broadway. So you can see it gets a little packed. And, during this instant, obviously, we shut down all of Broadway. But it also, if you look, this is the CMAs, was a couple weeks before. One of the cool things we're able to do is we're able to play this back and speed this up and actually view what the pedestrian impact is, how they're moving, where the stops are. It's an incredible technology to use, and using also, if you take this technology and then you match it with like Derq, we're using Derq down here as well. You put the two together, and it's a very impressive program for us to be doing. We're able to classify, we're able to figure out the trajectories. We're going to start using the SDLC conversion tool on these ouster boxes to set up detection zones for advanced stop bar and departure zone for each of our signals that have these on them as well. That's also coming down the road. And then as you get to doing LIDAR, you can actually start to take a look at what is going on, and you can actually match it up to, so we ran a drone. This was done by Vanderbilt for us again, mind you. These guys are an incredible group to work with. To take the LIDAR data, put it over the top of a drone data, and you can see the impact that this system is going to have on Nashville. So that is, I just have to show that one. That's, I thought that was pretty cool. Or, I mean, we can run helicopters, and I don't know how many of you guys were able to see this one. Wish we would have had the LIDAR for this one as they were taking the goalpost down Broadway, but of course that didn't happen. Helicopters are a little more expensive to run, so we're going to stick with the LIDAR. All right, James, that's all I really have.
Aaron, can I ask you a few things?
Sure.
First of all, can you talk a little bit? I think privacy is a big deal.
Oh,
can you talk a little bit about
yeah.
that, please?
So one of the real big things with the city of Nashville and Davidson County in general is we at Nashville DOT, we do not record any video. And with LIDAR, it allows us to have these devices running everywhere. We're able to get the pedestrian counts, the pedestrian movements, bicycles count, bicycle movements, vehicle count, vehicle movement, every bit of data that we're going to need to improve that intersection, improve the flow, hopefully go adaptive signal technology through this entire area, all off of a system where we're not picking up any personal information. We're not picking any PII whatsoever out of the deal. It's all anonymous data. We just know that there's a contact, there is somebody there.
Aaron, how many sensors did you have to deploy to get these?
So on Broadway, we have 10 right now. There's 5 intersections running through there. On Clarksville Pike, we have 16 altogether. And hopefully for Smart Grant Phase 2, we'll have about 157.
Cool. And then the last question that I have, and you've got some questions in the box that maybe you can answer, we can answer in the overtime, is I saw you had an integration with your transit system right up there in the first one. Can you talk a little bit about your integration with your transit?
One of the big things that we're trying to do is we're going to eventually be running TSP through this corridor as well. So having that bus information as far as who's on time, who's behind, being able to then use the LIDAR to see where the platoons are at, where the flow is at, how can we speed that signal up to get that bus through faster? So all of that's going to be working in unison, especially as we migrate into a new ATMS system for Nashville. All of that data is going to be in there in our adaptive signal technology, working with TSP and EVP through this corridor. All that's going to play a part.
Very cool. Well, you're not sitting on your laurels either. You're looking at the next one. Do you want to introduce Jaime a little bit about what he's going to talk about?
All right. Well, yeah. So Jaime Sullivan is with Derq, and just an amazing. If you guys have not seen the technology behind Derq, we're using it on Broadway as well. I did not bring up that because I didn't want to steal any of Jaime's thunder. It's hard enough talking for 15 minutes. So, but what Jaime does is going to play hand in hand with what we're doing because you have to have that see it as well as act on it. So Jaime is going to show you some really cool stuff here with Derq.
Very good. Jaime?
Okay, so hopefully you guys can hear me now. I'm going to turn off my camera just for video bandwidth purposes. Aaron and I are sharing a conference room here and at the USDOT, so we'll probably be giving each other feedback off of our laptops. So, so again, thanks, Aaron. As Aaron kind of talked through the LIDAR, we look at video as a complementary solution for LIDAR, multiple sensors collecting the data and kind of feeding off of each other and the ability to kind of take object data from either system and work with both of them. So Derq predominantly uses video as our ground truth and our core system, simply because it's one of the most deployed sensors out there. It's very easy to be a software-based solution and work through all the different camera deployments and those kinds of things that are out there. We like the visualization piece and the ground truth as well, and then certainly from a cost perspective as well. But as we kind of see the future, we see these technologies beginning to merge, and multi-sensor types of solutions are going to be the norm here pretty soon. So from Derq, we look at it as, what can we do from a next gen, traffic system? So don't deliver me just something that'll, focus on detection, but give me analytics, give me connected vehicle, connected infrastructure, digital infrastructure capabilities. So have that ability to not only detect, but track, classify, and then, also, predict, right? So the visualization piece, looking at how do we, provide that, SPAT data to the stop bar, visualizing these things, collecting all the data around zones, activations, pet activity, and how does this all kind of interact and play together at the intersection, right? So as Aaron and I are here at the USDOT and the Smart Grant conference, there's a heavy focus on safety. And I think they talked about it for a good 20 minutes this morning or this afternoon. And it's a big component of what we're focused on. It's at our core. So, additionally, then as we kind of think about from the detection, looking at the analytics, but now getting into this, prediction and intent, right? So using the existing infrastructure, in this instance, predicting the intent of somebody to enter into the roadway. So you look at those flashing beacons. This is in Dubai, but doing some of these here in the U.S. as well, in Florida and Michigan. But using the infrastructure to predict intent, right? So the beacon begins to flash, we predict intent, and then as they enter the roadway, the intensity picks up. So these are examples of how we can use the existing infrastructure to be visual warnings or alerts for people who are not in connected vehicles, right? So it's a long way before everybody it gets to that kind of technology. So how do we use the existing things today, like the street lights up above, mobile applications, communicating to all those different things to really kind of help, warn drivers and pedestrians of each other and where those conflicts are going to be. Heavy focus here at the USDOT on collision avoidance at the intersection. So, this is a good example of, just PED extensions, PED cancellations, minimalizations, preemptions, those kinds of things. So if somebody's fallen in the crosswalk or needs more time to cross, how do we do extensions? And then, looking at individuals as they kind of, maybe enter back into the roadway and kind of doing preemptions and all reds and those kinds of things. So additionally, as we kind of look at that, how do we collect the data to kind of build into the dashboards, right? So collecting the analytics to help provide the imperial data that everybody knows about particular locations that, oh, that's a dangerous spot. Now you have the empirical data that will tell you the things that you kind of have implied. And then, this ultimately leads to some of the countermeasures, right? So as we look at, this is Denver and some of the locations, experience a high number of crashes on unprotected left-hand turns, right? So knowing when those are happening, times a day, days a week, et cetera, the city can now start to make adjustments and start to look at times a day, days a week when, unprotected left-hand turns are not permitted. So how do we use the analytics to kind of, reach real-world countermeasures and solve for those things, right? So as we get into Nashville, as Aaron talked about, what's happening down on Broadway, if anybody's been there, it is actually, absolutely a pedestrian fiasco. It's people everywhere, and certainly the days, as Nashville would say, that the city or the street being open to vehicle traffic are probably limited, and it eventually, kind of turn into a pedestrian area. But focusing on safety scores, these what's happening with illegal crossings, near misses, crashes, right? That's going to really drive these safety scores, red being bad, obviously yellow being caution, green being, operating as it should or expected. How do we start to look at the events that are causing those safety scores to go up or down, right? And this gives Aaron and team the visualization to kind of very quickly look at locations and understand whether things are operating as they should or they need some attention. Ranking locations based on safety scores, as I talked about, or if you want to look at prioritization, maybe the mayor's after, red light violations, right? You can start to rank the locations based on different events and applications and start to tackle these problems, one at a time, right? Using the data that's coming out of the dashboard. And then, heat maps, as we could imagine, Aaron showed with the LIDAR, video complements that in terms of understanding where we can drill down into these individual tracks. Look at what and where and why people are crossing in the places that they are. Is there a bus stop? Is there a convenience store? Or is it just a good honky-tonk bar that people are trying to get to, right? So really drilling down into those kinds of things. We have the video evidence of folks either crossing, et cetera, right? So just random events. And then, what are the things that are driving people to that? As we think about near misses, we can look at the hot spots of where those are happening on the roadway at the intersection, drill down into the red spots, the hot ones that are high severity. Why are these happening, right? So just looking at some of the videos of, you can see the foot traffic in that's down there. You get a lot of folks that maybe cross against the signal. Vehicles aren't aware of that. So you have a lot of instances where, relatively benign near misses, but they're near misses nonetheless. And, how do we use the infrastructure to help avoid some of these things, right? And then as we think about, some of the connected infrastructure, the onboard systems can't see around these vehicles, right? So they're going to miss that pedestrian. So how do we use some of that data to start to use in vehicle systems, something similar to what they're doing in California, right? So how do we kind of embed that data into in-dash systems and that as you think about these left-hand turns and challenges that they provide. As we kind of look at the counts, Aaron talked about a lot of, from a resource perspective, public safety, depending on how many people are down there, they need to allocate for resources. So, we can kind of slice the data a lot of different ways to help them understand, how many thousands of people are at a particular intersection in a particular hour or a minute through comparative analysis through different days, 4th of July to Labor Day, things like that. Days of week, times a day, so helping them to really understand how many resources and what they need to look at that. And then the last thing I'll just talk about is, looking at speeding. This is a high profile issue, especially in crowded areas like Broadway, where approaching into some of those areas where if you have vehicles going at a high rate of speed, are they looking to crash barriers? Are they going to cause problems? And really understanding times of day, days of week. So some of these are pretty obvious on Broadway. You know when those things are going to be most likely, but certainly in the intersections surrounding and leading into the area, this could be important data to help understand from a safety perspective. So James, that was all I was going to cover there for the Nashville pilot.
I appreciate it, Jamie. And Jessica put a great question in the chat here, and I kind of want to expand on it. Her initial question is, what is Derq's definition of a near miss? But I kind of want to go a little bit wider on that, right? Like, and not to pick on you or anything, this concept of safety score is something that people get a lot of. And it seems like, every private entity has their own version of a safety score. I don't imagine there's a solution now, but how do we get to a spot where transportation professionals know what a safety score means? Are they standardized? Or is there something? What's the way that we get there, or does that already exist in some way?
Yeah, so the way we define the safety score, and it leads into the near miss conversation. The safety score is really defined by the events that are happening, right? So the near misses, the crashes, the illegal pedestrian behavior, illegal vehicle behavior, all those kind of begin to pile up, and those really determine what the safety score is. And it's not a scientific measurement, but it's based on customer feedback on being built by some traffic engineers from a multitude of cities that really want to focus in on particular events. And the safety score can be modified to focus on just vulnerable road user behavior, or it could be focused on vehicle behavior. So there's the opportunity to do a mix of both. As we talk about, the near miss, right, there's no standard or definition for that either, right? There's no standard or definition for the safety score. This is within the software and the tool now, though, you can set those parameters and you can define it, right? So a near miss in Nashville is probably different than a near miss in New York City. And those things are going to be tantamount to being able to localize the data, right? So the end user can then really kind of build parameters and metrics around what's germane to the specific part of the country or the city that they're in, and not have to live with maybe a standard that doesn't really apply to their city.
Got it. Yeah, it makes sense. I'd be interested to see a poll of the ops community to see how they feel about those sorts of things. But I appreciate it. Yeah. Let's go on to the next Jaime on this call, Jaime Pierce. Jaime is from, I don't know if you're from Fort Worth, but you live in Fort Worth currently or surrounding areas. You work for TxDOT and TransVision. Jaime, tell us what you got for us.
So what I'm working on here today is called Traffic Vision, and it's something separate from, well, first of all, can everybody see my screen? Did I do that right?
We don't see your screen yet. We see your name.
There we go.
Here it comes. All right, good to go.
All right. So basically, what how this call came about was we did some comprehensive analysis based on our fatality review teams, and we determined that our pedestrian fatalities were increasing significantly. Along with that was our wrong-way driver, and we decided that we needed to find some fast solutions to not only identify but hopefully try to prevent these incidents from happening. What we ended up coming up with is we found this company, Traffic Vision, and it's a software solution that transforms standard traffic cameras into intelligent sensors. It uses advanced analytics and an algorithm, and unlike LIDAR, which employs the laser-based technology, Traffic Vision will leverage existing camera infrastructure to monitor and analyze traffic conditions in real time. So going back to our pilot program, which was a 5-month period, we identified 574 people on a 7-mile span of roadway that were walking on our highways. So the percentage or the likelihood of accidents happening and pedestrians being killed is pretty high, because again, that's only a 7-mile stretch of highway. So we'll go over here to the right. We'll just pick a location like Hewlin. You see the black lines is where the algorithm lines up with the lanes of traffic. The green is the parameters from where people will walk, and within a certain distance will actually pick up and send us a notification that a pedestrian, or even what we found good for also is stopped vehicles, congestion, wrong way drivers. It really is kind of a catch-all, but there is a couple catches with that, because unless we are using fixed cameras, or unless you're using fixed cameras, having the PTZ makes it difficult to hold the algorithm. Meaning, even the slightest variation. So here we have a pretty good setup here, but if I were to come down here to beach, you can see there isn't one at all. So even though the green boxes are detecting and actually counting traffic in this case, because somebody moved the preset, it's not catching everything the way it should. So as you can see here, everything's kind of off to the left. We'd have to go back and fix that in order to make it work again. But going back to kind of what we're talking about here, it's been a game changer. So every time we catch somebody walking on the freeway, we call 911, and easily a month we save 20. The way we look at it is we save 20 people a month, because that's about the number of times that we are calling 911 or contacting the police, or even our courtesy patrol element, which will go out there and take them off the road and take them to where they're going, or at least off of that busy stretch where the traffic is driving close to them and not paying much of attention. So wow, I mean, that's really about it. I mean, it's been a great tool. We are using it. So within that first 7 miles, it was only on nine CCTVs. Since then, we've increased that to 70, and now we've added it on our West Loop, where we've had some pretty tragic wrong way driver incidents. We've employed it up there to hopefully try to catch the wrong way drivers and contact 911 before somebody else dies or another crash happens where tragic loss of life. So wow, I mean, all in all, it's really been great. So
Hey, Jaime, can I ask you, so we always hear, right, TMC staff have a lot going on, right? And you see you've got your false alarms there. And I know like in Houston, they tried a system and they weren't great because there was a lot of false positives. What has been the methodology to sort of get TMC staff on board? I mean, they're going to have to reconfigure the lines and then move the camera, what a pain, right? But what's the methodology to get their heads on board with this?
So whenever we come up with an SOP. So whenever we have a notification here on the right-hand side, it'll turn red, green, yellow, whatever, however we have the alert set up. They will have to go in, and so you can see here they have we catch a little a thumbnail, and then we can false positive, or if it's a true event. In the event of a true event, because we did see this vehicle on the side of the road, we can go in and create a ticket for that and have it removed within 48 hours. So we don't have to worry about the secondary incidents. But to keep their heads on a swivel, they're required to keep the software open. Now, we are trying to integrate it into our ATMS into Lone Star. We're having a little bit of a hard time with that, but we are making progress. But in the meantime, it's literally just, hey, this is your responsibility for the day. When one of these pop up, confirm, deny it, create a ticket, monitor, and then Charlie might continue mission.
Yeah, so it sounds like having that champion at the executive level. I mean, I always hope that folks who do this, say, oh yes, it's a pain, but here's the great benefit that we're getting. Like you said, lives are being saved, but it's important, yourself and Teresa and everybody at the district pushing this forward. It sounds like.
No, absolutely, and we are actually we're actually in talks to hopefully try to employ or deploy this software and even more cameras. The next step on that is to try to get some static cameras, so we don't have to worry about the PTZ and having the algorithm come offline because it got bumped or the wind's blowing too hard or just something goes down. So it's a work in progress, but overall it's been a game changer.
Excellent. Okay, let's go to Mark. Mark is going to take us a little bit of a different direction. Ops are, yes, cars on the road, but there's also signs and signals. It's your assets on the road. over time as well. And Mark is really just, I think most people on this call, you probably have seen Mark in one of these before. What an industry leader and a great guy. Mark, go ahead.
Yeah. Thanks, James. Really appreciate the time here. Really excited to hear, the advancement of technology in the industry. As I built a business and look to the future, it's really exciting to see what's coming next and how that's evolving. Particularly the use of LIDAR, which is something we're looking at as well. But the technology that we've kind of focused our energy on is very similar, but also different in some ways, right? We're using AI, or using AI on cameras, and you saw some video in Jaime Sullivan's presentation from a dash cam view. And we see the dash cam, the very humble dash cam, as an incredible technology to help us make sense of what's going on our roadway infrastructure from a pedestrian perspective, from a vehicle perspective, and from an asset infrastructure perspective, right? Our physical infrastructure is the most valuable thing we own as a society. I mean, just think about the physical cost of repaving a roadway, building a sidewalk, and aggregate that all together over time. Making sure that infrastructure is supporting the safety of our pedestrians, our bicyclists, and of course, our motorists is paramount. And how do we do that in a really scalable and fast way? So, we've looked at a lot of technologies over the years, and what we've really come to see as an incredible part of the value here is the use of crowdsourced dashcam imagery to make sense of what's happening on our infrastructure. So Blinksy publicized on our website in October of 2024, the first open source national US freeway network map of certain asset detections to help make sense of what's going on. So that includes things like work zones, identifying the presence of traffic control devices on your work zones, reporting that data in kind of near real time, and using an image to validate that, right? So much of our human experience is lived through our perception of reality, and that's really governed by what we see. So we thought to ourselves, why not use the camera imagery coming from the vehicles on the roadways themselves to make sense of this? It's inexpensive, it's scalable, and more importantly, it comes from the heavy users of our roadway infrastructure. It's the semi-trucks, the last mile delivery vehicles, Uber and Lyft vehicles, and others that are really leaning into this technology for their own purposes. And that gives us a really incredible view. It helps us understand where the infrastructure might be failing in a given location, might help us understand where there's impacts to a variety of different asset applications on our roadways. And most exciting, some of our newest opportunities are around using this technology to identify the presence of pedestrians and bicyclists. So just a few weeks ago at NASTO, we announced our open source open API and the ability to now query pedestrian and bicyclist counts using crowdsourced dashcam imagery. As you're looking across your entire county, region, or maybe state, one of the first questions might be, well, where should I even prioritize? Where should I focus? Right? So these cool technologies like LIDAR at the intersections, even the use of Derq, first you got to know where to prioritize the use cases there. For MPOs, trying to understand from a planning perspective where the pedestrian bicyclist volumes are, and also, what kind of infrastructure is being used by which kind of people. We think this is an incredibly scalable technology that leverages and combines insights and information collected from vehicles on the roadway in near real time with powerful AI applications to extract from those images the intelligence necessary to make a decision. In many of our use cases, these things are scalable and fundamental because they come from the vehicles on the road. And this really allows us to do some incredible things at scale. What you're seeing here is the use of AI technology to analyze crosswalk visibility and scoring in New York City DOT, right? How do you understand, well, one, for your pedestrians and bicyclist volumes are, but two, what infrastructure to provide them to improve safety? Knowing when the pavement markings are degraded to the point that a vehicle might not know where the stop bar is, or it might not see the crosswalk, which means it might not see a pedestrian, are really paramount. And how do you leverage different insights from your infrastructure into one powerful application to draw these things out individually? For example, now I know the pedestrian and bicyclist volume on a given roadway. I can identify if the crosswalks might be faded, but I've got 5,000 crosswalks maybe in my region that I'm trying to manage. So how do I prioritize that with other data sets? For example, is the street light out at that location? If there's no illumination of the crosswalk at night and the pavement markings are faded, maybe there's a higher risk of pedestrian fatalities or pedestrian vehicle conflicts. Leveraging and combining our data to understand where our pedestrians, our vehicles are, and the condition of our infrastructure is the paramount next step in actually delivering intelligence that's practical and useful, because so much of our operations today are still operations, construction, and maintenance of our infrastructure. Making sure that infrastructure is working for everyone and doing that in the safest possible way is crucial. But of course, there's massive cost savings available here as well. Knowing where to spend your time is, of course, very valuable. scale. But when it comes to much of our infrastructure, we're looking for applications such as identifying when there's a pothole on the ground. If that pothole is small, it can be fixed with a very small patch treatment. It's very inexpensive. If that pothole grows too large because you weren't aware of it, now you might have to actually degrade your road base and dig up that section of the roadway, leading to a much more expensive repair on that infrastructure. These such applications combine to deliver us massive cost savings, incredible value and efficiency to our public servants, and of course, benefit the traveling public in so many different ways. So as we think about these technology applications, as we think to the future, we really see opportunities to kind of leverage this in exciting new ways. And that includes combining these data sets to understand how things might be changing at scale. So the use of LIDAR-based technologies, for example, that traditionally are used to measure things through a point cloud, are now being combined with imagery to identify and understand the differences between them. In this example, we are actually able to compare LIDAR point cloud data, guardrail lengths, to what we see in our imagery data sets. And we're finding these data sets within 98% of the measurements of ground truth LIDAR, enabling incredible new expansions at low cost and very inexpensive scaled data collection compared to high resolution and fairly expensive LIDAR data collection. How do we combine these two data sets in the most efficient way? How do we understand the benefits and the drawbacks of each of them and employ them in the right way and perspective? And of course, over time, we believe more and more of these technologies will become cheaper and cheaper, right? As the widespread use of cameras in vehicles and automotive use cases becomes more prevalent, more data becomes available. As more images become available, you get different angles and perspectives, which allows you to measure depth. And if you combine that with data sets like LIDAR and high fidelity point clouds, you can start to understand a whole new level of what's happening on the roadway. So these are exciting ways that we see this technology evolving. And in October, we're excited to announce the kind of next data offering services that we're projecting to change the game once again in the transportation industry. That's all I've got here.
Cool. Well, like everybody else, I have a few questions for you. That LiDAR, man, it's coming off the cars too. I think I've seen a UPS truck with the LiDAR on the top of it. Where are you sourcing that data from?
Yeah, we'll be announcing that partnership in October, James. We've got exciting partnerships with a variety of different fleets that collect different and disparate data sets. And like you kind of highlighted, we're seeing a massive change in the infrastructure, right? Vehicles are being equipped with all sorts of new technology, radar and LiDAR, camera technologies. The sky's just the limit. We're just getting started, and we're excited to see what else is available in the near future.
Well, and you did talk about a lot of different things. You know, you talked about potholes, you talked about seeing if the lights are out. Are these things that are possible? Are these things that your software does currently? What's your list of features that you can do now versus, what might be on the road now?
Yeah, it's a great question, James. Everything I've shown and just discussed is already live and in production and use with many of our users and customers across not only the country, but the globe. And that's really the exciting application. Pothole and pavement marking detections have been in use for several years now, nationally and internationally, using this technology, as have so many of our others. We have over 55 different asset detection categories, including now pedestrian and bicyclist detection, with some random ideas such as debris detection and vegetation encroachment of your assets. For those of you who may live in the South or in areas with fast-growing shrubbery and trees and bushes, the mowing process can be very daunting, right? In many states, we've heard from a lot of our customers, they're limited to how often they can actually mow, right? Given the constrained resources they have. How do you know when to go mow at the right time, at the right place? When your assets being encroached, these are the types of services and intelligence that we want to leverage at a massive scale at an incredibly low cost.
Yeah, I think that the cost is an interesting thing. There's you and there's a few other folks that are in this area as well, and we've been looking at the pricing of these things for some work in Umatilla that my boss Adrian Piermine is on, and it's really affordable. It's not. It doesn't seem like it's big lifts, which is pretty neat to know that this technology is becoming competitive and becoming more affordable. So really appreciate it for the effort. So those are our panelists. We've got 20 minutes now. And so, happy to answer questions from folks as they come in on the chat line. We have some earlier. I will start with one that we got beforehand, and it's how can cities scale this when the hardware is so expensive? Why would they invest now when the space is so frothy and AI recognition so unreliable but improving? And I think we've seen some real world cases. So we've got a bunch of first movers on the call. what's the argument to continue moving first and, have people sort of continue to grow this? Mark?
I learned many, many years ago from one of the great transportation heroes, I think, in our space, Carlos Braceras, and the UDOT director, and he always says to me, we can't sit by and wait, right? And the opportunity here really is to explore these technologies that help you in a practical and beneficial way. So I'd encourage you to continue to invest in the leading edge and the cutting edge, but find practical applications for how you can use this, right? We looked at our technology and rolled this out in the space first, and we said, what's the thing that we can do to help augment the workload that's happening today? Things like pedestrian and bicyclist counts and detections came much later in the evolution for us. What was really practical in the beginning was things like guardrail damage assessments, identifying road safety audits, this sort of manually intensive, very expensive and hard to do work that's safety critical that oftentimes particular local governments in our cities struggle to be able to have the resources and the manpower to complete. If we can focus on an opportunity to bring these sorts of technologies to bear where they have the largest impact in your community, that's where you'll get the most bang for your buck. That's where you get the most support politically, and that's also where you'll find the sources of funding. And as we lean into these opportunities, particularly in maintenance and operations, we see how they fit so nicely together with safety and other operational use cases, right? Across the country, we've seen the construction and maintenance arms of our agencies really lean into these safety opportunities. And by providing these data sets for core, robust day-to-day maintenance and operations activities, you can combine them in a leveraged way to increase the safety of your roadway infrastructure.
Very good. Aaron, Jaime, any thoughts from y'all? Either Jaime?
Yeah, so are we on the scaling, James?
Yeah, well, just on the, why do this now?
Yeah, so I think from our vantage point and viewpoint, as a software-based system, we're kind of hardware independent and can work with a lot of different systems. And I think that's what the US DOT is looking at. If we're going to be very hardware centric, right? So if you can lead from a software-based perspective, then you can work with all the different systems that are out there. And I think that's how we scale, today until we have some universal guidelines from the federal government. I think that's the way we go about it.
Very good. Here was another one we received. It was very specific to traffic incident management and keeping first responders safe. Aaron, Jaime, maybe you all can take this. Jaime Pierce, how does this help keep your first responder community safe, which you all are deploying?
James, can you still hear me?
Yes. Can you hear me?
Okay. Yeah. So sorry, my Zoom's freezing up a little bit. But yeah, so I think from a first responder, we can use the data to create real-time alerts, give them eyes on the situation before they need to deploy assets, give them information about where the problematic areas are, where they need to focus. That's data can be very friendly and kind of looking at problems before they really get out there, and then helping to understand where resources need to be deployed, right? So much like we talked about Nashville, a big interest in Nashville is for public safety to understand how many people are down on Broadway and how many resources they need down there to manage it.
Very good. Aaron, are you still there?
Yes, sir. I sure am. Sorry. I don't know if it's the US DOT building or it's just me. It's kind of, so when you're talking first responders, one of the things that we're really doing is we're working directly with fire and police. We're giving them access to this data as well, so they can actually see it. It's not just in our traffic management center. The data doesn't do any good if we keep it locked in a box so that only we can see it. We need to share this. It needs to be viewed by every different agency, from WeGo, to waste management. They all need to be able to see what's going on. Where's the backups? What's the holdups? And then we'll use it to see how we can better configure the signals or the intersection to make things safer for everybody in the long run.
Very good. Jaime Pierce, anything to add?
No, not necessarily. It kind of works in the same manner. Really, it's just identifying or just using the AI-based analytics for faster alerts, accurate location information, and traffic condition insights. Just kind of gives a roundabout 360 view for us to tell first responders what's going on around them.
Very good. We've got a few questions here, sort of looking ahead already. You can tell the types of people that are attending this. And the question is, will these work with robotic delivery devices and new sorts of transportation technology that's going to be on the roadway? And then there's a correlation there, Aaron, I think it was for you, about can you classify vehicles? You want to talk about that a little bit?
Sure. A contact is a contact is a contact. If it's a robotic vehicle, if it's a Waymo, if it's an autonomous vehicle, it doesn't matter to the system. The system is going to detect and classify that vehicle as a vehicle. We've been pretty impressed with the LIDAR on Broadway. We can differentiate between a scooter, a Segway, a bicycle to a bus. We're able to classify all those types of vehicles, and this is going to help with TSP, with putting in extended ped calls. If we have somebody in a wheelchair making it slow across the road, we'll be able to put those extended calls in because we're able to classify that individual. And it just really depends on the ATMS system that you have, if they're able to accept a lot of that data as it's coming in.
Yeah, it's an interesting, it is interesting that as these new things come about, right, you kind of need them to work with legacy systems. Like Jaime, you talked about getting the new system to work with Lone Star to go forward. And I know sometimes, that it's difficult to make those connections work and to go forward, but it certainly is a big piece. And Aaron, of course, you've been so impressive with how you are aggregating data. Can you talk a little bit about how you're doing that? Is anybody here using a data exchange to move data back and forth between these different pieces, or are you just all sort of tying into a common system?
Right now, because we're in the infancy on this, we are using our partners at Vanderbilt to do all of our data crunch. We just don't have the manpower in-house yet to handle that kind of information. So with the help of Vanderbilt, we're able to have a data storehouse that any of the other universities that are helping us in these different projects can have access to that data to help us as well. So it's a really cool partnership with how we're doing it. Eventually, as we move into our new ATMS system, who we haven't picked yet, we're still working through that process. That data is going to be fed into there, and then will be fed out to different partners that are helping, aggregate that data and to do research on that data. But there's a lot of data. When you're talking, each one of those locations on Broadway puts out about 100 gigs of data per day per intersection. That's a lot of data to go through. I mean, it's very impressive to go through that much data.
That's the LIDAR is producing that much data?
Yeah, because of the number of points. I mean, when you're that saturated, you've got 15 to 20,000 people walking around on that road, the bikes, the scooters, the Segways, the horse-drawn carriage, the tractor pulling a barge, all that data there, all those contacts are there. And it's about 100 gigs of data per intersection per day.
Wow. Anybody want to hit that data exchange question before I go to the next one? No, we're good.
I might contribute real fast here, James. Yeah. We've been very large supporters of the WorkZone data exchange, of some of the new data exchanges, and tried to pioneer a bit of a safety data exchange many years ago as well. The idea of interoperability is incredibly important, incredibly critical for all those listening and attending today. As you think about these technologies, as you think about writing specifications, an open data architecture is the first thing you need to look to. That data doesn't do you any good if it's only stuck in the desktop application you might be using it in. It should be broad and interoperable. There's benefits to many, many stakeholders. And in fact, there's probably lots of benefit to the traveling public. How do you find ways to do that? Leverage these existing data feeds and data exchanges that exist today for that.
Very good. Let's talk a little bit about supporting infrastructure. Mark, I see a question maybe for you to start out. A little bit of confusion about how you're collecting these stuff. A lot of these tools, you don't have to do anything, right? Or it's
Mhm.
minimal. Talk a little bit about that.
Yeah, I know it's a great question. I think so often it's like so hard to wrap your head around the idea that this might even be possible, right? And sometimes I'm in shock and awe a little bit too at how this happened. So roughly 1.8 million vehicles in North America are connected to our dashcam network. These are semi trucks, they're UPS, FedEx, last mile delivery vehicles, you name it. They might be personal passenger vehicles, many daily active drivers that are going around every day with a camera in their vehicle for their own purposes, and through a variety of commercial agreements selling us some of that imagery in exchange for a benefit. And that data is being made available. So in many of these use cases, this data is available to us through that dashcam network. Oftentimes we partner with our local agencies who have cameras in their fleets already, or we help supply and supplement with other cameras as well where that might be needed. Through our partnership with Google that we announced in March of this year, we became the first company in the transportation industry to get access to Google Street View data, which will be going live here later this year. That gives us the ability to actually use 360-degree imagery in 100 megapixel resolution from Google Street View nationally to take a snapshot in time. And soon we'll be announcing the ability to actually work with Google on the recollection. When those roadways are collected, how often that data is collected. And again, in an open architecture type way, we want that available to public Street View and other use cases so that you benefit as a regular citizen also.
Very good. Jaime, either Jaime here, talk a little bit about that supporting infrastructure. I mean, do you need fiber optics? Do you need edge compute? Is it done in an Amazon cloud somewhere? Where's the work actually done for these applications?
Yeah, so the nice thing about being software first, we can live at the edge, we can live in the cloud, we can live in the data center. So depending on what the infrastructure that exists, we can work with what's there to specifically do analytics, right? If you're going to do latency driven kinds of things, then there's going to be an edge infrastructure. But as we talk with controller manufacturers, telcos, there's a desire to build that edge infrastructure for a whole host of different things that the software can run on. And I think some changes and some exciting things will start happening here in the next 12 to 24 months in that area. But the nice thing is that we can work very often with what's there, and make the use of the data that's for a lot of this technology that's already out there.
Aaron, are you guys using fiber backhaul to get all your information back in, or are you on a cell network?
Well, so we're a combination. Most of it is still on cellular. We are aiming and striving for fiber. It just makes life a lot easier when you're pushing that kind of data. But infrastructure, setting up fiber is not cheap. But that is our main goal, is to get everything on a fiber backbone, and then we don't have to pay a cell phone bill.
Mm-hmm. Aaron, I'm going to stay with you there. What does maintenance look like for that LIDAR? What's the lifespan of these sensors?
So we're shooting for a 10-year lifespan. I mean, that's what we've been working with, like Ouster on, is we want anything that we're going to be using taxpayers' dollars for to invest in. We want to have a longevity out of it. And I honestly don't think a 10-year want is out of the picture. I think that should be something that these manufacturers are striving to provide, something that the taxpayers are going to get their bang for their buck. We're going to be able to get the data we want, and it's going to last long enough. So that's our goal, is 10 years. Of course, we've had it up 2. We'll see how things go, right? I mean, you can never judge weather. You can never judge what 100-mile-an-hour windstorm is going to do to a device versus somebody deciding to use their car to tap a signal pole. These things happen, but I think overall we're shooting for a 10-year lifespan on them.
Just out of curiosity, do you ever have to go and clean the screens on your LiDAR?
No, we do. So we do, on just like anything, when we put up a camera, we set up twice a year we go out, we wipe them down, but you don't need to do any more than that because of the angle they're at, the material that the screen is made of. Nothing really gets sticked to it. And with the rain that comes through here on a regular basis, they kind of take care of themselves. But twice a year we do go out, we knock the spiders off and keep going.
Very good. Well, we've got 5 minutes left and I am out of questions. If anybody has any, now's the time to put them in. We will try to answer Otherwise, I think on the chat box or on the question here, is anybody on the panel, do you all want to say anything to close this out here? Are you all available for numerous emails and contacts for people asking you how they can do this same thing?
Definitely. Definitely. If they got any questions, shoot them my way. I can answer or find the people that do answer.
Perfect.
Yeah, absolutely, James. Thanks.
Indeed.
Great. Well, I really appreciate everybody. I'm going to turn it back over to Victoria to close us out.
All right, thank you everyone for attending the webinar today. As a reminder, a copy of the recording for this webinar will be posted to the ITS America website and our YouTube page. That'll be it from me. I will see you all later.
Thanks, y'all. Everybody be safe.